Hi guys, welcome back to the shop. Today I'm going to get started on the shift shaft for the RM250. As I'd showed you in the previous video, I didn't even have one. I had to get one, and the one I could get was bad. It was already wore out. So basically all I did was pay for a core so that I could make one myself. So that's what we're going to do today. I'm going to do two things. I don't know whether I'll get both of them done in this video or not, but I'm gonna make one complete shaft, and I think it'll be in another video. I'll take the old shaft that I have and redo it. Just cut off the part that's bad, or just cut the splines off and make new splines. I'll have to press a piece on, but the first one I'm going to do, I'm going to try to make the complete shaft, and it's not too long. I think it's about 7 inches long, so I'll hold it between centers and turn it with a dog, and we should be okay. It is only a little, it's about 475 as far as the diameter, so it is getting kind of thin. So we'll just have to see how it works. But on this one, I'm going to use drill rod to make it, oil hardened. I guess the reason I'm going to use it is because it's tougher than just 1018 or 1045. So I'm just going to go ahead and try to use the drill rod. Not that I'm going to heat treat it, but I may. I don't want to heat treat the whole thing, because if you crash and hit that, it'll just snap it off. So I think if we do anything, we'll case harden the end where the splines are. But anyway, with the drill rod, basically it's unhardened tool steel, so we'll be able to do that heat treating if we need to. So anyhow, let me get you overhead. I'll show you more of what we're doing and what I've already done, and then we'll get over to the lathe and get started on it. Okay, first thing I did was I just made me a kind of a drawing of this item, and that way I can make another one if I need to without having the shaft out. Now, this is pretty simple as far as machining it. The biggest thing we've got to do is we've got to machine down 1/2 inch drill stock, about 70 thousandths or 30 thousandths rather. About 470 for the most of the diameter of it. Right here at the end, it's actually up to about 475, and that's because it's a press fit into this into this piece. So let's see, this goes this way, and it's an interference fit down to here. This is how far it goes, and there's a pin that is in there, and this pin is a tapered roll pin. Otherwise, it's I think it's like 10 thousandths bigger on one end than it is the other. So it will only go in one way, and that's the way right there. So if you try to put it in this way, it's just not going to start. So that way it's a tapered roll pin, and that'll go all the way into this piece. And what I did to remove this, it wasn't too difficult. I just set this in the vise, set it on this edge right here, and just pounded that out with a brass hammer. And it didn't take too much to take it out. If you start trying to knock the roll pin out and it doesn't go pretty easy, turn it around and go the other way. That's because of the taper. Okay. So the other one, like I said, that I've done, it was made different and didn't have the pin. I had to cut the welds on one side, and actually it was swaged, I think, just kind of peened over type. And then when I put it back together, I went ahead and welded it with TIG. But we're about 7 inches long, and the majority of this is going to be at 470. And when we get down to this end, we'll do 475, and then this little piece is like 391. And then we'll cut it down to the dimension in order to get our splines cut on this end. So it should be okay. It's just I'm gonna have to see how it cuts. It should machine okay. So it's unhardened at this point. So let's get over in the lathe and set this up. I'm first going to just clean up the end, put a dimple in it, and then we'll turn around, put a dimple in the other end, and then we'll set it up with the faceplate and a dog between centers and turn the majority of it down. Okay, we'll just start by facing it off. I cut a little bit right here at the beginning just to see how it was going to turn. I think it'll do okay. It just depends on if it'll still do okay in the middle of a 7-inch turn. Hopefully it'll be rigid enough. I think it will. All right. And we'll just go ahead and put our dimple in here. Yeah, I think that'll do it. Okay, I've got this set up. I'm going to try to run it with the chuck. I think it's going to be okay between centers, and that way I don't have to cut anything off until I'm ready at the end. So let's see here. We were just about 0 there, and I think not quite as good up on this end. My chuck's got a little bit of run out, 2 to 3 usually. That's 1. That's good. There's nothing wrong with that. So that's how I'm gonna run this right now. And we've just got to take about 30 thousandths off. And here's the original. I'm just going to set it up here, and right here is about where the interference fit starts. So I'll just turn it to 470 or 471. I'll have to look again and see what it is. Down to that point. So that's the approximate places. So we'll just be first turning it down to this first mark. Okay, we've got this down to 471. That should be just right on target. And this one here we've got to bring to 475, I think. Let me double check. This is going to be for our press fit on the lever. 0.475. And we're at 5 right now. See where we're at. Yeah, 495. So we've got 20 thousandths to go. Okay, 475. I'm going to check it with my micrometer just to make sure. Right on the money. All right. Now I'm going to pull this. We're going to pull the center out and check our fit here. Let's see, this thing I believe goes this direction. Okay, so it's not going up onto the shoulder, so that's good, because that's got to be a press fit up there. Starts right here. Okay. So that's good. Now we'll come back down here. I think I'm going to have to put a half center in here if I remember right. But I'm probably going to go ahead and cut this off. This here will be cut even smaller right here. All this does is come up against the case, and it just keeps it from coming out too far. So that I can do after I put the splines on. So I think at this point I'll go ahead and choke this back up inside here so I can get closer to where I'm going to put the splines on. And I think I've got to get a half center and put in there to help so I can get my roller in there, my tool. So let me see what I can do here. All right, things a little different here. I've got a dead center, and instead of a live center, and we'll put a little high pressure lube. Just need to, you know, you know what I've got to do before I do this? I've got to cut this down just a little bit. let me get tooled up to do that first. Okay, got to take a little off of that first. And that's about where the splines are going to go to. We're just kind of setting a baseline here. We'll go from the measurement that we get here. I think we've got to take about 50 thousandths off. I'll check again when we get our baseline. I think this will be my last cut. Yeah, should be fine. Okay, now let me get set up to start the knurling. No. Seems to me like I've kind of got to start this without a center. And that means I'm going to have to get it in there just a little bit further. It's kind of coming back to me now. That's better being in there further anyway. But even with a half center, I am having troubles. Let me see what I can do here. This is a lot heavier material than I've done in the past. So let's see what we've got. Yeah, that's kind of how it starts, but it needs to straighten up here a little. Let's see. Okay, that's looking right. Yep, looking good. So you don't want to pull completely off the shaft with the tool. If you do, you'll have to line up your splines again. Okay, I'm just going to pull up to the edge here. Yeah, that's looking good. I'm going to go ahead and try to get my center in. That should give us a little more rigidity now. Just about done with it. Just got to try to get to the maximum depth. Once you get the splines established, it's not too hard to get back into it if you need to. Okay, it's looking pretty nice. All right. All right, it's good and tight. We'll have to spread this a little bit. But I can go ahead and finish it up because we've got the right, everything's right there. So let me get my file. And we'll try to work on the chamfer here a little bit. Okay. Now I got to get set up to put the relief in for the bolt. Okay, let's get this thing squared up. It's leaning back towards me a little bit, so we need to go a little higher. Still a little more. Now that's the other way. Oh, that's pretty good. Lock it there. And let me see about where that thing needs to be. Yeah, right. It's right in the center. Okay. I think right there is close enough. Let me get my other, yeah, we can do it with this center maybe. Yeah, let me get the live center in. All right, let's see if we can get this done. Sounds like something's breaking off, but I don't see it. Let me speed it up just a little bit. I think that's good. Maybe I need to widen it a little bit. I think I do. Okay, it's widened toward the front. Yeah, that looks good. Okay, I think we're done on that end. Okay, so I've got to go ahead and cut it back here. I believe that's right. Yep. Okay, I'll cut it back here and then I'll trim that down. So I've got to put it back in the other way. Let me get set up for that. All right. And slow it down a little. It's a lot harder material than I've done in the past for this. I don't think we're going to need to harden it at all. This is a lot better just to start with. And like I say, you don't want to, if you fall over, you don't want to break the shaft off. All right. I don't think it really mattered. Doesn't have to be that precise, but it's showing 2000s. Don't think I really need to worry about it, but we will. There we go. 391, right on the money. Okay, we've got a little burr there we can take care of with the file. Okay, it's time to press this back on, and I'm just going to set this kind of between parallels here. That should slide okay. All right, and I've got to get it down to where the hole is 1.092 from the end here. So we'll just start pushing on it. How's the lighting there? There. Okay. Let's see what that does. Give them a quick measurement. And go just a little further. Yeah, just a little bit further. It's really just about to the end of where we drop that taper down. Yeah, looks good. Okay, now all we got to do is drill it and pin it. And let that dry a little bit and we'll put her in there. And put a little Loctite on that pin. It goes in one side but not the other. And we'll start that with a brass hammer. Okay, there we go. So it should go in there. I'm not going to be able to get it in there with the clutch in there, but slides in okay, so we should be good. All right, guys, there's our new Suzuki 250 RM shift shaft. They're not out there. I don't have a Suzuki or an RM shifter, so I've got to just make do with a Suzuki, I think it's TS 125. They should all be the same. Much better. I think they'd had that welded on and pinned on. It's a bunch of different things they did there. So it should be good. Good and tight. So another part we don't need to find. They're just not out there. I haven't seen any. And this is actually easier to make the shaft than to cut this down, put a sleeve on it, and redo the knurling. I don't think I'd even do that. This is really pretty easy. All we had to do was take 30 thousandths off of the 1/2-inch diameter drill rod, and then up here we had to have 3 thousandths interference fit, I believe. So it was at 475, and then whatever this was here, and just turn our knurl. So that doesn't get too much easier than that. Okay guys, there you have it. New shift shaft for the 250 RM 1978 Suzuki. The spring just goes down over this and separates the two halves right here on this, and that ratchets it back and forth. And like I say, I haven't seen any. I considered myself lucky to have found that raunchy one that I had, and I'm ashamed to say that I think I give $28 for it, plus I don't know, a few, probably 20 some bucks, maybe $18.95 shipping. I think it was terrible. So it was almost 50 bucks for just a wore out shaft. I'm sure they're out there. I'm sure if you're in the know, you can probably find one. But I just have a heck of a time finding parts for these things, and I don't expect it to improve much. So I think people that know where to get the stuff, they're keeping their mouth shut because they don't want to not be able to find them like me. So hey, thanks for going along on the ride, and we'll see you next video.